Subtraction using 2's complement method. Subtraction using 2's complement method. So how subtraction is done is we take a first number and then we subtract the second number from the first number and we get the difference. So the number from which is being subtracted is called as subtrahend, and the number from which something is being subtracted is known as minuend, and the result is difference between those two. So subtraction using 2's complement method is preferred in microcontroller processors. To perform subtraction using 2's complement method, we need to do the following steps. First, we need to find 2's complement of subtrahend. If you are doing it manually, you need to find the subtrahend's second complement first, which means the reversal of this bits of this number and then adding 1 to it. Okay. Then you need to check the result for the carry. Then you add the second complements of subtrahend to the minuend and check the result for the carry. If there is a carry generated, then the result obtained is positive. Okay, and there is no further processing needed. Okay. If there is no carry generated, means that there is no carry is being generated, then the result obtained is negative and you have to do a second complement of the result obtained. Okay, so now, but there is also a note attached with this kind of subtraction using 2's complement with the method using addition. So when doing subtraction using 2 complement, pay close attention to the sign of subtrahend and minuend and the result, because there is conditions where a overflow flag is generated because system does not have the what do you call it, the memory, the register in which the result is being stored does not have enough spaces to hold the number which is being supplied by the result, so a overflow flag is being generated. Okay, and the result will be wrong. So how can we detect whether there is a so there are two main conditions that in which the overflow is being generated when the two numbers of the same sign are added together. If you are adding positive plus positive and the result becomes negative, then there is a overflow flag will be generated. And if you add negative plus negative and the result comes out to be positive, the overflow flag is also generated. So let's see how this overflow. So I have written a small program in IAR Embedded Workbench to showcase this. So first I have done is I have created 3 variables of signed integer, and there are 32 bits each, and they are signed. So 0 to 31 is going to be the data bits, and the 32nd bit 0 to 30 is going to be your data bits, and 31st bit is going to be your sign bit. Okay, now first result is I am adding 2 plus negative 5. So now let's go into a project and then we make this file. Okay, so total number of warnings are there. Okay, so there are some warnings. because I have not used this result anywhere. Now I need to go press F7 again, and everything is done, configuration is up to date. Okay, now we click on this download and debug button, or we can also press Ctrl+D in IAR Workbench. So let's do that. So starting debugger, and here is my STM32L476G on which this result is being produced. So here we have a disassembly of the program. Here we can see the register view, and what we are interested is in APSR, and APSR is arithmetic program status register, and in that we are interested in this V position bit, which is overflag bit. C is your carry, Z is for 0, and N is if the result is comes out to be negative, then this will tell us if the result is negated or negative. Greater than, and Q is your saturation. So we are interested in this V bit. Okay, so now let's I have also added this watch window with the three expressions A, B, and result. So now we need to click on this. Okay, so first we need to go down, and yes, we have added our breakpoint. So now we need to click on this go button, and it will stop at this breakpoint, and here you can see it is stopped at the NOP instruction, just as I told it to. So assembly NOP and then NOP. I am also going to mention that I have turned off all the optimization options for in this IAR setup to do these kind of things, because if I do any optimization, IAR will just throw this result out of this way, because none of these are used somewhere in any kind of operation. So this is garbage to IAR right now. Okay, first we will calculate. We have initialized three variables A, B, and res result. They are both of type signed integer and of 32 bits. A is initialized with the value of 2, positive 2, and B is initialized with the value of negative 5. Now we have started our debugging. We will click on this button for next statement. Here we have a disassembly view. Here we have our registers. We are particularly interested in the V or overflow flag, and in this watch expression I have added so that we can quickly see what is the result of the operations. So now we will click on next statement. Next statement will increment one statement, execute one statement at a time. So now A will contain 2, B will contain negative 5, and RES will become 0, and now RES will contain negative of 3. Negative of 3, which is correct result, and you can see there is no overflow flag or carry flag is being generated. Okay, now we will click on next statement. Now I have a new condition which says A equals to negative of 5 and B equals to negative of this number, and if we add the result, we should get a result with a positive value, and as I have told you that when two numbers of the same sign are added together, they produce a result, a opposite sign, which is the condition for an overflow. So now let's see what happens. Now I'll click on next statement. A will contain negative of 5, B contains negative of that huge number. Now result is equals to 0. Now result will be executed. Now as you can see, a negative and negative plus negative we should get a negative value, but we are getting a positive value, and the carry flag is set to 1 and overflow flag is set to 1, which indicates that this result is wrong and it is overflowed. Now I have a new code which adds two positive numbers two positive numbers. Okay, now we'll click on next statement. So A now contains a 2 to the power of 31 minus 1, B contains 5, and result becomes 0, and the result is negated, so negated flag is set to 1 and overflow flag is set to 1. Carry flag is not set because there is no carry being generated. Okay, now now let's read the value of APSR. Which contains 5, so 5 is 1 0 1 0 1, and fourth bit is set to overflow flag V, and 0 flag is set to 1, so there is overflow flag. So using this underscore get underscore APSR in IAR Workbench, you can read the APSR register. So this register is in CMSIS library. So if you right click on it and go to definition, it will take you to CMSIS ICC arm.h header file, and here you will have your APSR defined.